Hi friends, today I am going to start the part 3 of the chapter first matter, chemistry. And guys, if you want to listen the part 1 and part 2, so I have given that both videos link in the description, so you can listen from that link. Shall we start? The conservation of mass. You know that only a rearrangement of atoms or molecules takes place when a change occurs. So when a change occurs, the important is the rearrangement of atoms or molecules that takes place when a change occurs. And as the atoms or molecules of a substance has fixed masses, the total mass of the substances involved in a change should remain the same. And as we know that the atoms and molecules have fixed masses, and the total mass of the substances that involved in a chain should remain the equal, same. And next, law of conservation of mass. Lavoisier in the late 18th century gave a law called the law of conservation of mass, which can be stated as follows. So here Lavoisier is a scientist, great scientist in late 18th century. That what he gives a law that is known as law of conservation of mass, and its define is matter can be neither be created nor destroyed, but can be changed from one form to another, and the total mass of the substances before and after change the remain same. It explains that matters can neither be created or nor be destroyed, but it can be changed from one form to another, and the substance's total mass and its before and after the change remains equal. The law of conservation of mass is true for physical as well as chemical changes. In a nutshell, the total mass of the substances before and after the change is the same. It has given the example that in a nutshell, the substance's total mass before and after change remains same. And next here is a small definitions of physical changes and chemical changes. Physical changes. It is easily understood that there is no change in the mass of a substance when it undergoes a physical change. So, when there is no change in the mass of any substance, then it undergoes a physical change. So here they given an example that the mass of an electric bulb does not change after it remains lighted for some time. So we can't change the lighting of the electric bulb. And similarly, another example is of ice. A mass of ice on melting give the same mass of water, and a given mass of water on boiling give the same mass of water vapor. So here is also physical change. And next is chemical changes. According to the law of conservation of mass, in a chemical change, the sum of the masses of the reactants is same as that of the products. So the sum of the masses of the products remains same as the sum of the masses of reactants. We must look at the total mass of the substance before and after the reaction. So here is a way that mass that shows that mass of the reactant is always equals to mass of the products. So let us consider the burning of a piece of paper. So here is another example that if we consider a burning piece of a paper, during the process it appears that there is a loss of mass. Obviously, when we burn the paper and we think that it lost a mass, but that is not the case. In fact, while burning, the paper takes up oxygen from air and forms some ash plus carbon dioxide and water. So while we burn the paper, that paper that goes burned, that paper takes oxygen from atmosphere or air and adds some ash plus carbon dioxide and water vapor. So paper adds carbon dioxide and water vapor. So we have to see whether or not the mass of a paper plus oxygen taken from air is equal to that of the ash plus carbon dioxide and water vapor. They tell that so now we have to see that the that when paper burnt paper takes oxygen from air and add carbon dioxide and water, they remain same or not. And that detailed experiment shows that the two masses are equal. So there is a experiment that shows the two masses are equal. And when we add mass of a paper and oxygen, and when we add mass of ash plus carbon dioxide and plus water vapor, so they both remain same. And you can verify the law with the help of a more simple experiment as described below. And they describe an experiment that they are starting. Put a small tube or bottle containing a solution of barium chloride into a conical flask. And next, here is a conical flask, and we should put this small tube which contains barium chloride. Next, place some sodium sulfate solution in the flask with the help of a dropper carefully. So here in the flask we should add sodium sulfate solution with the help of a dropper carefully. Next, ensuring that the two substances do not come in contact with each other. So we should ensure that these two substances, that barium chloride solution and sodium sulfate solution, do not come in contact, do not merge with each other. And close the mouth of the flask with the cork and weigh the flask. And next step is to close the mouth of the flask with the cork or a weight. Tilt the flask and swirl it slowly. Next step is to swirling the flask slowly and also tilting the flask. By tilting and swirling, a white precipitate is formed. So, white precipitate is formed by swirling. And leave the flask for some time and weight it again. You will find that there is no change in the weight of the flask. So, by leaving the flask for some time and afterwards we should weight that object again, and by weighting we ensure that there is no change in the weight of the flask. So till there, our first chapter of matter of chemistry is finished. And guys, please subscribe and like my channel, and please subscribe my channel and I will also make a video about this chapter exercise and also the question answers. So please subscribe my channel to see the exercises and question answers and other and further videos that I will upload. Thank you guys. Thanks for watching.